Good morning. Today is kind of a quick tutorial on how to make your own battery charger. We're talking about for 12 volt. I mean, you could do it for 6 volt, 24 volt lead acid batteries. This is not for nicad. This is not for lithium ion. This is purely lead acid batteries. So to start with, the minimum you need to make a battery charger for lead acid batteries is a transformer, a full wave rectifier, and which could be some diodes, and a battery. I mean, that's it. It's a little bit more complicated than that because it's kind of difficult to find a transformer that meets the specs that one would want for making a battery charger. And it kind of depends on what kind of battery you're charging, whether it's a sealed lead acid battery, flooded cell lead acid battery, an AGM. Each of those is going to kind of change the voltage that you want. But for the most part, we're going to talk about flooded lead acid batteries of the car or marine deep cycle type. So what we have two circuits here. Both of these are full wave rectifiers. One of them will provide output more voltage than the other. And so what we'll do is, in order to get the voltage needed to charge a deep cycle battery or car battery, you want your output voltage without load to be either between 14.4 and 15 volts. The ideal charging voltage for most lead acid batteries is about 14.4 volts. You can charge it with less. I think you can charge it down to, if you had 13.8, but that's going to give you a trickle charge. And the reason you'd want to go up to 15 is that when you're charging a deep cycle battery or even a car battery that may have been heavily overcharged, you have to do what's called a maintenance charge. And what that is you supply 15 volts and you charge the battery for longer than 8 hours. Typical charge time for a lead acid battery that's been fully discharged is between 6 and 8 hours. A maintenance charge is between 12 and 16. And the reason for charging it that long, based on information that I have read, is that when a battery gets over discharged or it's had a lot of cycles on it, it starts to build up sulfites on the cells, and you're having to basically convert that back into sulfuric acid. And over time it gets harder and harder for that to happen, which is why batteries eventually die. And by charging the battery with 15 volts, it helps to reconvert the sulfates back into the acid, and it causes the formation of oxygen and hydrogen in the water, which causes bubbles, which stirs up the electrolyte, and this prevents stratification in your battery, especially if your battery's been sitting a long time. We won't get into the chemistry of batteries or anything else other than that's the basic reasons why you would charge a battery at 15 volts. The batteries you would not charge with 15 volts are the AGM, the glass mat, the spiral wound batteries. It's my understanding that it's bad to charge those with anything higher than 14.4 volts. I have seen manufacturer spec sheets for batteries that say you can, but I don't know, the prevailing information I have says not to. So anyways, so let's get into designing a battery charger. And hopefully I've got a pen that works. And what you need and some of the problems you're going to run into. So the first thing you're going to need is, if you're going to use a transformer, you can pull transformers from various devices. But the voltage that you're going to get the voltage you need, the output voltage, if you're not familiar with how this circuit works and what the voltage is, this is called a linear power supply. And when you put a load on it, especially like if you put a capacitor, a smoothing capacitor, which is not needed because your battery is the smoothing capacitor, you get a voltage that is 41% higher than the voltage put out by your transformer. So let's say you have 120 volts in, and this transformer puts out 11.1 volts AC. When you do the math and then you compensate for the dropping voltage of the diode or diodes, you get 15 volts. So with a full bridge rectifier without a center tap, it would have to output 11.1 volts to get 15 volts on this side. Now you're going to have a hard time finding a transformer that puts out exactly 11.1 volts. Usually in battery chargers, the transformer in question puts out they're specially made. And so, really, if you were going to make a battery charger, you could take an old battery charger and pull the transformer out of it and use it. There's some ways we can get around the oddball voltages. We'll go into that in a little bit. If you use, and this is with a full bridge rectifier, if you use a full wave rectifier using two diodes, which if you look at any old style, old-fashioned battery charger, they are almost always made this way. They have two diodes in this configuration with a center tap. And your center tap is your negative, your positive is the output from the two diodes, and you get a full wave rectification. The difference is that the output of this is half of what your transformer puts out. So in order to get 15 volts out of this, we actually have to have I believe it's 22.2 volts from both sides of this. And when you do this, you get half the voltage out of here that you would here. And so this one was going to output 15, and this one's going to output 15. Okay, so let's say you can't find a transformer that puts out at 11.1 volts, and you've got one that puts out 12 volts, or more commonly 12.6 volts, or some other amount. So I'm going to put, you can't see this, I'm going to put 12.6 volts into my calculators. And what we get out of this is approximately 17.12 volts out, and what we would get out of this is 8.21 volts. Which is too much. So what you can do is you could put on the positive side, you could put another diode, and by doing that you would drop the voltage by 0.7 volts, and that would drop the voltage to 16.42. So, doing it this way, you would need 3 extra diodes. So, that's, you can do that, but it's not ideal. The other way you can do it is that, I should have prepped a little bit better for this. You can use a buck converter like this one. This one can handle, I believe it's 12 amps, and something like 30 volts. I'd have to look up the specs. But the thing is that you need something that is current limiting. In lead acid batteries, when you're charging your battery, you want a current limiting battery charger. Most of the old style dumb chargers kind of are self current limiting. When you put a load on them, if it gets close to the maximum of the transformer, I don't know exactly how it works, but you'll notice if you put a voltmeter on a dumb charger when it's charging a very heavily discharged battery, the amp meter will go up to 6 or 7 or 8 amps, but the volts will drop down, and you want that. That's a good thing. So if you use something like this, then you definitely need current limiting, because the likelihood is that any transformer you find is going to have too high a voltage. So let's say you got a 12.6 volt AC output, and that puts out 17.12 volts with a full bridge rectifier. That's fine. That's as long as you've got a current limiting buck converter. You just plug the plus and minus into this, you set your maximum voltage, you set your current limiting, and you can hook it up to a battery and it will charge the battery just fine. The key thing you have to remember with dumb chargers is that you can't just leave them. They will keep charging and charging until all the electrolyte is boiled out of the battery. They don't care. So you have to have a timer, or you have to monitor it, something. Now, you can also, I did not fully plan. You can also use a power supply like this. These are common on eBay. They are adjustable. You can get them where they put out 15 volts. However, as you can see with this one, it's 40 amps. Its current limiting will be 40 amps. And you do not want, on your batteries, when you're charging a lead acid battery, you do not want to charge it any higher than the battery is rated for charging. And what that is, there's some calculators online, and if you look up manufacturer's specs, certain types of batteries have limits. If you charge something like this, it has a current limit for charging of about, I think it's either 2 or 3 amps, and it recommends that you don't charge it with any more than that. And if your charger puts out 8 amps, it doesn't mean that your charger is going to shove 8 amps into it, but it does mean that the battery can draw more current than it should be, and a battery will draw what it wants. So if the battery wants to draw a current of 4 or 5 amps, it'll do that, but it may not be good for the battery, and that's why you need current limiting. Most automotive dumb chargers they're usually in the 6 to 10 amp range, and most car batteries and deep cycle batteries are fine with being charged between 6 and 10 amps. It won't hurt them. It's usually within their rated charging capacity. There are some things about car chargers or battery chargers that some people don't seem to understand. Most people think that if a battery charger has a high amperage rating, it's better. You know, you'll see battery chargers that say something like 10 amps charging, 2 amps trickle, 55 amps starting. Or you'll see these rolling battery chargers that can put out 100 or 200 amps. And so some people think, well, if I've got a battery that's dead and I hook it up to this, I can charge it with 200 amps. Well, no, you can't. The battery probably won't pull 200 amps. Those kinds of chargers are actually meant to augment trying to start a car with a low battery or dead battery. That's why they put out 100 or 200 amps. You'll never get a battery for a car that needs to be charged more than 10 amps. Nor will they usually pull much more than that. I think maybe you might get a really dead battery, might pull 15, but you'd be surprised, because I have seen dead batteries that don't pull 2 amps, and they're so far gone that they have such high internal resistance that they just don't draw anything. So, you know, having a 100 amp charger does not mean you're going to get 100 amps charging of the battery. Maybe with one of those giant batteries that you see on large diesel engines, the charging current might be 15 or 20 amps. I don't know. But Anyways, so if you do use something like this, there's some things you have to understand about them. One, you have to get one that's adjustable. Most of them are. I would get one that says it's adjustable at about 15 volts. They're usually adjustable up or down by 2 or 3 volts. And if you're going to use a switching power supply, you're going to need a buck converter. And the switching power supply needs to be set a couple of volts higher than the voltage you need, because the buck converter is going to decrease that voltage, but it's going to need more voltage coming out of the power supply than what you're going to supply, and usually that's 10% higher voltage than what you need. So if you want 15 volts to come out, you're going to need 16.5 to 17 volts from your power supply. So you might want to go with a 20 volt switching power supply, a buck converter with current limiting, and the other thing is the amp rating of your switching power supply. You want to go 20 to 30% higher than what you're expecting to charge a battery with. So if you need 10 amps max to charge a battery, then you're going to need 13 to 15 amps from the power supply, because the power supplies, I only found out recently, they're really only meant to run at 80% capacity for a long period of time. So, if it says 40 amps, you have to derate that by 20% for what it actually will put out. So let me think here. Oh, yes. All right. So there's one other thing. If you don't have two diodes like these are 10 amp diodes. And normally the way you would do that, we got a small transformer here. Is for this type of circuit, you would hook up like this. This is your negative. These together are your positive. But let's say you don't have two diodes, or you can't get diodes that are a high enough amperage rating. You can use one of these. This is a full bridge rectifier. This one is rated for 1000 volts at 50 amps. And how you would use this is, you can see I've marked where the AC goes in. These two are AC, and you have plus, and plus, and then this would be minus. The way you can use this is, as you can see here, you put your AC here, you take your positive off here, and you take your negative off the center tap, and you can ignore this. This is going to give you too high a voltage, but if you do it from here, you're going to get half the voltage. The other thing about this is that you can get two different voltages. That could help you in some way. You could use one voltage to run a fan, or who knows what, I don't know. But that's how you use a full bridge rectifier in this configuration, is you just put your AC here, take your positive out here, and use your center tap. If you don't have a center tap, you can't do this. You have to use a full bridge rectifier. And be mindful of the ratings of your buck converter. Do not exceed them. If it says 30 volts, That's the max. Now, how do you find a transformer that is the right size? Well, obviously this transformer is too small. This thing is only rated at 1 amp, and it's 6.3 volts center tap, so it's 12.6 volts max at 1 amp. This is great for a trickle charge, and that's about it. What you need is something like this. This came out of a UPS, and I believe it came out of a it was a 3 or a 4 battery UPS. I know 3 is a weird one. But anyways, I have hooked this up to power, and I have determined that with 120 volts in, it puts out 31 volts on one side, 31 on the other, and this is a center tap. This, I'm not sure what it is for. It might have been for a secondary voltage connection. I don't know. And of course, there's no information on these transformers. If you look up these numbers, most of the time you get no information. I can tell you that class 155 means that this transformer can work up to 155 degrees Celsius, which is 311 degrees Fahrenheit. So this thing can get pretty hot and still be okay. Most transformers you'll find will say class 135, which means that they can do 135 degrees Celsius or 275 degrees Fahrenheit. Once again, that's pretty damn hot. But how do you determine what the amp rating is for a transformer? Well, if you know the rating of, say, if you got it out of a UPS or something that has a rating on it, you can kind of discern it from that. Like if this was, say, a 1200 VA, then theoretically, if say this is 1200 VA or about 1200 watts, then based on the 61 volts that you could get out of this, that means that it's rated for 19 amps. If you don't know any other information other than the output voltage, and the only way to find that out is you figure out which side is your mains and which one is your output. Usually the heavier, in the case of UPSs, the heavier one is output and the thinner ones are your input. So you put 120 volts in, and ideally you would put it on a variac, and you would measure the output voltage. If you should see hardly any amp draw on this side. If you start putting voltage on this and you get a high amp draw, then there's either a short or you're hooked up to the wrong wires. So, but let's say you plug in 120 volts and you don't get hardly any amp draw. You bring it up to 120 volts and then you measure the voltage. You measure the voltage across both these terminals, and from one terminal to center tap to the other terminal center tap. You should get, like in this case, 62 volts on both of these and 31 volts going to the center. The next thing you want to do is you look at if there's wires visible, and here there's no wires, but luckily we've got the center tap. And if you look at this, it says on it, I found it earlier, 10 AWG. So that's 10 American wire gauge. Now, there's a rabbit hole of determining what the maximum amperage is for a particular size of wire, and it all depends on many factors, and some of which are, you can go by how many amps, the ratings. You can go based on what you would use in a house, but then there's amp ratings for DC, there's amp ratings for stranded and solid wire. It gets really complicated. There's an amp rating for power transmission and chassis wiring. And so if I were to pull up the amp rating for chassis wiring from a source I have, it says that this wire can handle 55 amps. But I don't know, it doesn't say whether, if that's in free air, what kind of temperature rise you're going to get from it. And of course, I would never run this at 55 amps because it's probably going to be pretty warm. If you go with the ampacity ratings based on house wiring, for 10 gauge wire, you're looking at about 30 amps. So that gives you a basic kind of idea of what the maximum amount of amps you can pull from this. And you never want to go to the maximum, but let's say you need 10-15 amps and you've determined that it's probably, you can get 30 amps out of this wire, 10-15 amps is less than half, then this thing's going to have no problem running your battery charger and charging a battery. If you find that the wiring says that 10 or 15 amps max, then you're going to want to put a current limit of, if it's 15, maybe 10, and if it's 10, 8, that kind of thing. So that's the basics of building or designing a lead acid battery charger. Hope this helps, and later.